Now in this class we are going to discuss SN1 unimolecular nucleophilic substitution reactions and also neighboring group participation and also that is SNI mechanism. Now the first one is SN1 mechanism. So here SN1 reaction, here what is SN1? One means unimolecular nucleophilic substitution reactions. This is a unimolecular nucleophilic substitution reactions. Let us discuss regarding SN1. SN1 ఎందులో జరుగుతుంది ఏంటి? యాక్చువల్గా ఏంటంటే న్యూక్లియోఫిలిక్ సబ్స్టిట్యూషన్ రియాక్షన్స్ అనేది ఆల్కైల్ హాలైడ్లో మ్యాక్సిమం మనం కాన్సన్ట్రేట్ చేస్తాం. ఇప్పుడు ఒక ఆల్కైల్ హాలైడ్ తీసుకొని SN1 ఎలా జరుగుతుంది అదేంటి అనేది చూద్దాం. Here we have one example here. This is CH3. Here we have this side is C2H5. Here we have this side it is C3H7. C3H7. This is a C3H7. Here we have leaving group. Here this is treated with water. Here it is treated with water. What happens? So in the presence of this solvent, what happens? This solvent, this one also acts as a nucleophile, and here we get this product. This is CH3. This is C2H5, and here it is C3H7. This is above the plane, that is below the plane. Here we have this side is OH, and here one more. This is OH. This is CH3, and here this is C3H7. This is C3H7. Below the plane is C2H5. Here we got two products. One is a retention product. This is I ఎక్కడి నుంచి వెళ్ళిపోతుందో అక్కడే OH మైనస్ వచ్చింది. దీన్ని ఏమంటాము? దిస్ ఈజ్ కాల్డ్ రిటెన్షన్ ప్రోడక్ట్. దిస్ ఈజ్ ఎ రిటెన్షన్ ప్రోడక్ట్. రిటెన్షన్ అంటే సేమ్ కాన్ఫిగరేషన్ ఉంటుంది. ఒకవేళ దీనిలో R ఉంటే అక్కడ కూడా R ఉంటే దట్ ఈజ్ రిటెన్షన్ అంటాము. ఇక్కడ I మైనస్కి ఆపోజిట్గా వస్తే దట్ ఈస్ కాల్డ్ ఇన్వర్షన్. Here we have two products. In this one we got two products. One is retention product, another one is inversion product. So let us discuss that mechanism, how this reaction takes place. First of all, this is CH3. This is here it is C2H5. Here it is this is C3H7. This is C3H7, and this is iodine. So first of all, here this is a slow step. This is a slow step. Slow step is nothing but rate determining step. Slow step is nothing but rate determining step. Here ionization takes place. Here we get this is CH3. This is here it is C2H5, and this is C3H7. And here we get carbocation. Here carbocation intermediate is formed. Here the hybridization of this one is sp2 hybridization. The hybridization of the carbon is sp2 hybridization. sp2 hybridization means this is a trigonal planar. It is a trigonal planar, and the next one is attacking of H2O. It is a H2O. This is a trigonal planar molecule. ఇది ఎలా ఉంటుందంటే ఫ్యాన్ లాగా ఉంటుంది. ఇందులో C3H7, C2H5, CH3 మూడు కూడా ఒక ప్లేన్లో ఉంటాయి. అయితే ఇక్కడ H2O అనేది పైనుంచి అటాక్ కావచ్చు, లేదా H2O అనేది బ్యాక్ సైడ్ నుంచి కూడా అటాక్ కావచ్చు. పైనుంచి అటాక్ కావచ్చు, లేదా బ్యాక్ సైడ్ నుంచి కూడా అటాక్ కావచ్చు. ఇక్కడ మనకు రెండు ప్రోడక్ట్స్ ఫామ్ కావచ్చు. ఒకటి రిటెన్షన్ ప్రోడక్ట్, ఇంకోటి ఏమో ఇన్వర్షన్ ప్రోడక్ట్. దిస్ ఈజ్ C2H5. హియర్ దిస్ ఈజ్ C3H7. This is C3H7. Suppose if it is attacked here, this is OH, here it is H plus. Suppose if it is attacked here, we get this is one more product. This is CH3. Here this is here we have this is C2. This is C2H7. This is C2H5, and this is C3H7. Here this is C3H7, and here it is this is C2H5. Here this we have this is OH, here it is plus. H2O అనేది ముందు నుంచి అటాక్ కావచ్చు, లేదా బ్యాక్ సైడ్ నుంచి కూడా అటాక్ కావచ్చు. అప్పుడు ఈ ప్రోడక్ట్ ఫామ్ అవుతుంది. తర్వాత లాస్ ఆఫ్ H ప్లస్. ఇన్ దిస్ వన్ లాస్ ఆఫ్ H ప్లస్ మైనస్ H ప్లస్. Here H plus is lost, there also H plus is lost. We get the product. This is CH3. So this is C2H5. here this is C3H7, this is C3H7, here we have this is OH, and here one more, this is CH3, here this is here it is C3H7, and here it is C2H5, here it is OH, here it is OH. సో ఈ ప్రోడక్ట్ అబ్జర్వ్ చేసినప్పుడు మనకు అవి వచ్చాయి, ఈ ప్రోడక్ట్స్ వచ్చాయి. ఇక్కడ మనం మెకానిజం గమనించినప్పుడు, ఇఫ్ యూ అబ్జర్వ్ ద మెకానిజం, హియర్ ద ఫార్మేషన్ ఆఫ్ కార్బోకటయాన్ ఈజ్ ఏ స్లో స్టెప్ అండ్ దిస్ ఈజ్ ఏ ఫాస్ట్ స్టెప్. Here rate depends on the concentration of only alkyl halide. It depends on only on the concentration of alkyl halide. It never depends on the concentration of nucleophile. ఎలా మనం SN2 రియాక్షన్లో తీసుకున్నప్పుడు SN2 రియాక్షన్లో అక్కడ రేట్ డిపెండ్స్ ఆన్ ద కాన్సన్ట్రేషన్ ఆఫ్ ఆల్కైల్ హాలైడ్ అండ్ కాన్సన్ట్రేషన్ ఆఫ్ న్యూక్లియోఫైల్. కాన్సన్ట్రేషన్ న్యూక్లియోఫైల్ మీద డిపెండ్ అవుతుంది, ఆల్కైల్ హాలైడ్ మీద డిపెండ్ అవుతుంది. న్యూక్లియోఫైల్ బ్యాక్ సైడ్ నుంచి అటాక్ అవుతుంది, అది ఫార్మేషన్, అది స్లో స్టెప్ అది. కానీ ఇక్కడ కూడా ఫస్ట్ స్టెప్ ఈజ్ ఎ స్లో స్టెప్, ఓన్లీ దట్ రియాక్షన్ టేక్స్ ప్లేస్ ఇన్ వన్ స్టెప్, బట్ దిస్ రియాక్షన్ టేక్స్ ప్లేస్ ఇన్ 2 steps. Sometimes some reactions it also takes place 3 steps, but maximum reaction, this reaction takes place in 2 steps. This is a formation of carbocation is a intermediate. This is an intermediate. This intermediate, it can be separated from the it can be isolated. దీన్ని ఐసోలేట్ కూడా చేయొచ్చు, కానీ ట్రాన్సిషన్ స్టేట్ మనం ఐసోలేట్ చేయలేం, ఇది స్లో స్టెప్. ఇక్కడ H2O బ్యాక్ సైడ్ నుంచి అటాక్ కావచ్చు, లేదా ఫ్రంట్ సైడ్ నుంచి అటాక్ కావచ్చు. మనకు 2 ప్రోడక్ట్స్ వస్తాయి, ఒకటి రిటెన్షన్ ప్రోడక్ట్, ఒకటి ఇన్వర్షన్ ప్రోడక్ట్ వస్తుంది. సో దాన్ని రెసిమిక్ మిక్చర్ అనొచ్చు. ఇందులో ఒక చిన్న పాయింట్ ఏంటంటే, ఇక్కడ రిటెన్షన్ ఇన్వర్షన్ ప్రోడక్ట్లో రిటెన్షన్ అనేది సమ్వాట్ మైనర్, ఇన్వర్షన్ అనేది సమ్వాట్ మేజర్. ఒకవేళ ఇది 45% ఫామ్ అయితే ఇక్కడ 55% ఫామ్ అవుతుంది, ఇది 55% ఫామ్ అవుతుంది, ఇది 45% ఫామ్ అవుతుంది. ఎందుకంటే న్యూక్లియోఫైల్ లివింగ్ గ్రూప్ ఎటు నుంచి ఎలిమినేట్ అవుతుందో అటువైపు నుంచి న్యూక్లియోఫైల్ అటాక్ అయితే కొంచెం స్టీరిక్ ఇండెన్స్ వలన రిటెన్షన్ ప్రోడక్ట్ అనేది తక్కువ ప్రోడక్ట్ ఫామ్ అవుతుంది. తక్కువ అంటే దట్ మీన్స్ అది 55% అయితే ఇది 45% ఫామ్ అవుతుంది. మనం దీన్ని రెసిమిక్ మిక్చర్ అని కూడా అనొచ్చు. Rate is directly proportional to concentration of alkyl halide. Rate only depends on the concentration of alkyl halide. Why? Because the formation of carbocation is a slow step. Here it never depends on the concentration of nucleophile. So in this reaction, rate equal to K into Rx. So here in this reaction SN1 reaction never depends on the concentration of nucleophile, Here this is first one, so therefore it is a first order reaction. This is a SN1 reaction. It is a SN1 reaction. Rate is next. Let us write that is energetic diagram. In energetic diagram, if you observe this one, in the reaction which we are discussed here, ఇందులో రియాక్షన్ ఏదైతే డిస్కస్ చేసామో దానిలో మనం ఎనర్జెటిక్ డయాగ్రామ్ తీసుకున్నప్పుడు ఫ్రీ ఎనర్జీ వర్సెస్ రియాక్షన్ కోఆర్డినేట్. మనకి ఇక్కడ ఫస్ట్ ఆఫ్ ఆల్ ఇంటర్మీడియట్ ఈజ్ ఎ కార్బోకటియాన్. సో హియర్ we have this is a transition state, and this is one more thing, and this is in this reaction we have like this. This is transition state 1, this is transition state 2, this is a transition state 3. Here we have 3 transition states, transition state 1, transition state 2, transition state 3, and here we have intermediate 2 intermediates. This is intermediate 1, and here in this one intermediate 2. యాక్చువల్గా మనకు మ్యాక్సిమం రియాక్షన్లో ఇంటర్మీడియట్ 1నే కన్సిడర్ చేస్తాం, ఇంటర్మీడియట్ 2ను కన్సిడర్ చేయం. కానీ ఇందులో పర్టికులర్ రియాక్షన్లో 2 ఇంటర్మీడియట్స్ వస్తున్నాయి. ట్రాన్సిషన్ స్టేట్ 1 ఏంటి, ట్రాన్సిషన్ స్టేట్ 2 ఏంటి, ట్రాన్సిషన్ స్టేట్ 3 ఏంటో చూద్దాం. ఇన్ ట్రాన్సిషన్ స్టేట్ 1, దట్ ఈస్ దిస్ ఈస్ CH3. హియర్ దిస్ ఈస్ what is happening here, this is here it is we have C2H5, here we have this is C3H7. In the C3H7, here first of all this iodine undergoes cleavage. This is the transition state 1, and the transition state 2, this is CH3, and here it is transition state 2, C2H5, and here this is C3H7, this is a carbocation, this is not a transition state, this is a intermediate one, this is the intermediate one, carbocation intermediate is formed. Next one, transition state 2, transition state 2. In transition state 2, the formed carbocation, here we have that is CH3, in this one this is C2H5, here it is C3H7, C3H7. So here attacking of OHH, here it is plus. So this one, and we have one more transition state 2, we have two compounds may be formed. This is C2H5, not like this, this is here it is C3H7, this is C3H7, backside is C2H5, here this is OHH, here this is transition state 2. Then transition state 2, then intermediate to 2, Here intermediate 2 is this is CH3, this is C2H5, here it is C3H7, here it is OHH, here it is plus. This is intermediate 2. And one more intermediate, that is intermediate 2, that means OH, H2O, it is that side, H2O may be this side, and H2 at side ఉండొచ్చు, H side ఉండొచ్చు. దీని నుంచి ఒక ఇంటర్మీడియట్ ఫామ్ అవుతుంది, దీని నుంచి ఇంటర్మీడియట్ ఫామ్ అవుతుంది. తర్వాత మనకు ట్రాన్సిషన్ స్టేట్ 3 కావాలి, ట్రాన్సిషన్ స్టేట్ 3. ట్రాన్సిషన్ స్టేట్ 3 అనేది ఇది ట్రాన్సిషన్ స్టేట్ 3, దిస్ ఇస్ CH3, దిస్ ఇస్ C2H5 and this is C3H7, and here it is OH, here it is plus this one. This is the transition state 3. This is the energetic diagram of SN1 reaction. SN1 reaction, this is rate is directly proportional to concentration of alkyl halide. It never depends on the concentration of nucleophile. So this is the first order reaction, energetic diagram. So this is the energy diagram of particular that reaction. Maximum reactions or SN1 reaction takes place in 2 steps, but here loss of H plus is also present. Therefore, I was indicated here that is 3 transition state. I am indicated here 3 transition state: transition state 1, transition state 2, and transition state 3. Here intermediate 1 and intermediate 2. Here the intermediate is carbocation. Intermediate is a carbocation. Therefore, in rearrangement maybe takes place. ఏదైనా రియాక్షన్లో ఒకవేళ కార్బోకేటయాన్ ఫామ్ అయితే అక్కడ రీఅరేంజ్మెంట్ జరిగే అవకాశం ఉంటుంది. SN2 రియాక్షన్లో రీఅరేంజ్మెంట్ జరగదు, అటాక్ అవ్వడము వెళ్ళిపోవడము. ఇక్కడ మాత్రం కార్బోకేటయాన్ ఇంటర్మీడియట్ ఫామ్ అవుతుంది కాబట్టి రీఅరేంజ్మెంట్ జరిగే అవకాశం ఉంటుంది. నౌ ద క్యారెక్టరిస్టిక్స్ ఆఫ్ SN1 రియాక్షన్. దిస్ రియాక్షన్ టేక్స్ ప్లేస్ generally in 2 steps, and here it is through carbocation intermediate. Here the carbocation intermediate, therefore rearrangement maybe takes place. Here in this one, this is rearrangement maybe takes place. That means racemic mixture is formed. Somewhat enantiomeric excess is also formed. Enantiomeric excess EE also formed. Enantiomeric excess also formed. In this reaction, that is retention product, both retention and inversion products are formed. Retention and inversion products are formed. If the intermediate is carbocation intermediate, formation of carbocation is a slow step and rate determining step. So retention and inversion products are formed, right. So after this one, so what are the factors which affects the rate of SN1 reaction? That is factors that affects the rate of SN1 reaction, factors that is factors affecting on rate of SN1 reaction, or which factors affects the SN1 reaction. First of all, that is structure of alkyl halide. There also we are discussing regarding structure of alkyl halide. Here also we are going to discuss structure of alkyl halide. How the structure of alkyl halide affect the rate of SN1 reaction. See here again, let us take the 4 compounds. This is CH3I. In the previous case also, in SN2 reaction also, we are taking 4 compounds. Similarly, also we are taking here 4 compounds. This is the tertiary alkyl halide. This is a tertiary alkyl halide. This is a tertiary butyl iodide. Similarly, you take this one. This is C. This is I. This is CH3. This is CH3. This is CH3. And here it is H. This is CH3. This is a secondary. Similarly, this is C. Here it is H, this is H, this is CH3, this is a primary, and here also this is CH3, this is CH3 and I. This is a methyl iodide, methyl iodide. In this reaction, actually the intermediate is carbocation intermediate. In the previous reaction, the intermediate is not a carbocation nucleophile attacks from the backside of the leaving group. Therefore, that in that reaction steric factors affects the rate of SN2 reaction. But here it is not required steric factors. Here now we have to concentrate on carbocation intermediate. Where carbocation intermediate is formed, if the carbocation intermediate is formed, that is stable or unstable, that we are deciding. That will decide the rate of SN1 reaction. ఇక్కడ చూద్దాం, ఇక్కడ టెర్షరీ కార్బోకేటయాన్ ఫామ్ అయింది అనుకోండి. టెర్షరీ కార్బోకేటయాన్ ఇట్ ఈస్ మోర్ స్టేబుల్ దాన్ సెకండరీ కార్బోకేటయాన్, సెకండరీ కార్బోకేటయాన్ ఈజ్ మోర్ స్టేబుల్ దాన్ ప్రైమరీ కార్బోకేటయాన్, ప్రైమరీ కార్బోకేటయాన్ ఈజ్ మోర్ స్టేబుల్ దాన్ మిథైల్ ఐడైడ్, మిథైల్ కార్బోకేటయాన్. అంటే ఫామ్ అయ్యేది మోర్ స్టేబుల్, టెర్షరీ కార్బోకేటయాన్ మోర్ స్టేబుల్ కాబట్టి ఇది మోర్ రియాక్టివ్. దట్ మీన్స్ టెర్షరీ ఈజ్ మోర్ రియాక్టివ్ దాన్ సెకండరీ, సెకండరీ ఈజ్ మోర్ రియాక్టివ్ దాన్ ప్రైమరీ, ప్రైమరీ ఈజ్ మోర్ రియాక్టివ్ దాన్ మిథైల్ ఐడైడ్. అంటే రియాక్టివిటీ ఆర్డర్ తీసుకున్నప్పుడు tertiary alkyl halide is more reactive than secondary alkyl halide, secondary alkyl halide is more reactive than primary alkyl halide, primary alkyl halide is more reactive than methyl halides. This is reactivity towards SN1 reaction, reactivity towards SN1 reaction. This is a decreasing order, this is a reactivity towards SN1 reaction. SN1 की SN2 की మనం అబ్జర్వ్ చేస్తే SN2లో ప్రైమరీ ఈజ్ గ్రేటర్ దాన్ సెకండరీ ఈజ్ గ్రేటర్ దాన్ టెర్షరీ, SN1లో టెర్షరీ ఈజ్ గ్రేటర్ దాన్ సెకండరీ ఈజ్ గ్రేటర్ దాన్ ప్రైమరీ ఈజ్ గ్రేటర్ దాన్ మిథైల్ హాలైడ్. అది కూడా ఇక్కడ రాద్దాం ఏది కంపారిజన్కి. టెర్షరీ ఆల్కైల్ హాలైడ్ ఈజ్ లెస్ రియాక్టివ్ దాన్, టెర్షరీ ఆల్కైల్ హాలైడ్ ఈజ్ లెస్ రియాక్టివ్ దాన్ సెకండరీ ఆల్కైల్ హాలైడ్, secondary alkyl halide is less reactive than primary alkyl halide, primary alkyl halide is less reactive than methyl halide. This is reactivity towards SN2 reaction, this is reactivity towards SN2. In SN2 reaction methyl halides are more reactive, in SN1 reaction tertiary alkyl halides are more reactive. And one more, ఇక్కడ ఎలిమినేషన్ కూడా చూద్దాము. E1 E2 ఎలిమినేషన్కి ఆల్కైల్ హాలైడ్స్ యొక్క ఎఫెక్ట్ ఎలా ఉంటుంది. E1 E2 తీసుకున్నప్పుడు ఎలిమినేషన్లో టెర్షరీ ఆల్కైల్ హాలైడ్ ఈజ్ మోర్ రియాక్టివ్ దాన్ సెకండరీ ఆల్కైల్ హాలైడ్, సెకండరీ ఆల్కైల్ హాలైడ్ ఈజ్ మోర్ రియాక్టివ్ దాన్ ప్రైమరీ ఆల్కైల్ హాలైడ్, ప్రైమరీ ఆల్కైల్ హాలైడ్ ఈజ్ మోర్ రియాక్టివ్ దాన్ మిథైల్ హాలైడ్. ఇది E1 E2కు సంబంధించింది. ఎలిమినేషన్లో టెర్షరీకి E1 కానీ E2 కానీ టెర్షరీ ఈజ్ మోర్ రియాక్టివ్ దాన్ సెకండరీ, సెకండరీ ఈజ్ మోర్ రియాక్టివ్ దాన్ ప్రైమరీ, ప్రైమరీ ఈజ్ మోర్ రియాక్టివ్ దాన్ మిథైల్ హాలైడ్. ఈ కంపారిజన్ అనేది చాలా చాలా ఇంపార్టెంట్. టెరిషరీ ఇచ్చాడు అంటే SN1 జరుగుతుంది, ప్రైమరీ ఇచ్చాడు అంటే SN2 జరుగుతుంది. మనకు తలనొప్పి అంతా ఎక్కడ వచ్చిందంటే సెకండరీ ఆల్కైల్ హాలైడ్లు, సెకండరీ ఆల్కైల్ హాలైడ్ అనేది SN1 జరుగుతుందా SN2 జరుగుతుందా. SN1 SN2 అనేది ఎలా జరుగుతుందంటే మనం న్యూక్లియోఫిల్ కాన్సన్ట్రేషన్ బట్టి, సాల్వెంట్ యొక్క ఎఫెక్ట్ని బట్టి మనం SN1 SN2 అనేది చెప్పచ్చు. ఇక్కడ మనం తీసుకున్నప్పుడు E1 E2లో తీసుకున్నప్పుడు టెర్షరీ ఈజ్ మోర్ రియాక్టివ్ దాన్ సెకండరీ ఈజ్ మోర్ రియాక్టివ్ దాన్ ప్రైమరీ ఈజ్ మోర్ రియాక్టివ్ దాన్ మిథైల్ హాలైడ్. సో దిస్ ఈజ్ రిగార్డింగ్ స్ట్రక్చర్ ఆఫ్ ఆల్కైల్ హాలైడ్. ఆఫ్టర్ స్ట్రక్చర్ ఆఫ్ ఆల్కైల్ హాలైడ్ నెక్స్ట్ వన్ ఈజ్ దట్ ఈజ్ నేచర్ అండ్ కాన్సన్ట్రేషన్ ఆఫ్ న్యూక్లియోఫైల్. నేచర్ అండ్ కాన్సన్ట్రేషన్ ఆఫ్ న్యూక్లియోఫైల్. నేచర్ అండ్ కాన్సన్ట్రేషన్ ఆఫ్ న్యూక్లియోఫైల్. సో హియర్ నేచర్ అండ్ కాన్సన్ట్రేషన్ ఆఫ్ న్యూక్లియోఫైల్ అబ్జర్వ్ చేస్తున్నప్పుడు అక్కడ మనకు స్ట్రాంగ్ న్యూక్లియోఫైల్స్ ఫేవర్స్ SN2 రియాక్షన్స్. హియర్ పూర్ న్యూక్లియోఫైల్స్ ఆర్ వీక్ న్యూక్లియోఫైల్స్. యాక్చువల్గా రేట్ ఇక్కడ తీసుకున్నప్పుడు రేట్ ఈజ్ డైరెక్ట్లీ ప్రపోర్షనల్ టు కాన్సన్ట్రేషన్ ఆఫ్ ఆల్కైల్ హాలైడ్. ఇక్కడ న్యూక్లియోఫైల్ కాన్సన్ట్రేషన్ మీద డిపెండే కాదు. నువ్వు న్యూక్లియోఫైల్ కాన్సన్ట్రేషన్ ఎంత పెంచినా ఎంత తగ్గించినా దాని రియాక్షన్ రేట్ ఆఫ్ SN1 రియాక్షన్ అనేది పెరగదు, తగ్గదు. రేట్ ఆఫ్ SN1 రియాక్షన్ అనేది ఓన్లీ ఆల్కైల్ హాలైడ్ కాన్సన్ట్రేషన్ మీదనే డిపెండ్ అవుతుంది. న్యూక్లియోఫైల్ కాన్సన్ట్రేషన్ పరిస్థితుల్లో ఎట్టి బస్సులో డిపెండ్ కాదు. నువ్వు వీక్ న్యూక్లియోఫైల్స్ అండ్ ఆల్సో లో కాన్సన్ట్రేషన్ ఆఫ్ న్యూక్లియోఫైల్స్ ఫేవర్స్ విచ్ రియాక్షన్? ఫేవర్స్ SN1 రియాక్షన్. అక్కడ స్ట్రాంగ్ న్యూక్లియోఫైల్స్ అండ్ హై కాన్సన్ట్రేషన్ ఆఫ్ న్యూక్లియోఫైల్ ఫేవర్స్ SN2 రియాక్షన్ అండ్ వీక్ న్యూక్లియోఫైల్స్ అండ్ లో కాన్సన్ట్రేషన్ ఆఫ్ న్యూక్లియోఫైల్ ఫేవర్స్ SN1 రియాక్షన్. ఒక ఎగ్జాంపుల్ తీసుకుందాం. రేట్ ఈక్వల్ టు K ఇంటూ RX. సపోజ్ ఈ రియాక్షన్లో మనం న్యూక్లియోఫైల్ కాన్సన్ట్రేషన్ 10 టైమ్స్ పెంచాము, ఆల్కైల్ హాలైడ్ కాన్సన్ట్రేషన్ పెంచలేదు, అప్పుడు రేట్ ఏమవుతుంది? రేట్ డస్ నాట్ చేంజెస్. ఒకవేళ మనం ఏం చేద్దాము, ఆల్కైల్ హాలైడ్ కాన్సన్ట్రేషన్ పెంచుదాం 10 టైమ్స్, రేట్ ఇంక్రీజెస్ బై 10 టైమ్స్. అంటే SN1 రియాక్షన్ అనేది ఓన్లీ ఆల్కైల్ హాలైడ్ కాన్సన్ట్రేషన్ మీద డిపెండ్ అవుతుంది, కానీ న్యూక్లియోఫైల్ కాన్సన్ట్రేషన్ మీద డిపెండ్ కాదు. కాబట్టి ఇక్కడ పూర్ న్యూక్లియోఫైల్స్, వీక్ న్యూక్లియోఫైల్స్ లేదా వీక్ న్యూక్లియోఫైల్స్ రెండు ఒకటే. వీక్ న్యూక్లియోఫైల్ తీసుకొని లో కాన్సన్ట్రేషన్ తీసుకున్నప్పుడు SN1 రియాక్షన్ అవుతుంది. ఇక్కడ ఏమీ లేదు, మనం కార్బోకేటయాన్ ఇంటర్మీడియట్ చూసుకోవాలి. అక్కడ తీసుకున్నప్పుడు మనం అక్కడ స్టీరిక్ ఇండెన్స్ తీసుకోవాలి. స్టీరిక్ ఇండెన్స్ ఎక్కువగా ఉంటే అక్కడ ఏమవుతుంది? న్యూక్లియోఫైల్ తొందరగా అటాక్ కాదు, అక్కడ అటాక్ అవ్వే అవకాశం లేదు. అందుకే టెర్షియరీని మనం అనగానే టెర్షియరీ అనగానే SN2 జరగదు, SN1 జరుగుతుంది. ప్రైమరీ అనగానే SN1 జరగదు, ఏం జరుగుతుంది? SN2 జరుగుతుంది. ఎందుకంటే ప్రైమరీలో స్టీరిక్ ఇండెన్స్ ఉండదు. ఇక్కడ మనము SN2 తీసుకున్నప్పుడేమో మనం ఏం తీసుకుంటాము? ఇన్ ట్రాన్సిషన్ స్టేట్ తీసుకుంటాము. SN1 తీసుకున్నప్పుడు ఏం తీసుకుంటాము అంటే కార్బోకేటయాన్ ఇంటర్మీడియట్ తీసుకుంటాము. రేట్ ఈక్వల్ టు దట్ ఈస్ విచ్ వన్? CH3C, C2H5 and C3H7 and it is I. సపోజ్ ఇక్కడ కాన్సన్ట్రేషన్ దీన్ని 3 టైమ్స్ పెంచామనుకోండి, రేట్ ఇంక్రీజెస్ బై హౌ మెనీ టైమ్స్? రేట్ ఇంక్రీజెస్ బై 3 టైమ్స్. సపోజ్ ఈ రియాక్షన్లో మనము న్యూక్లియోఫైల్ కాన్సన్ట్రేషన్ మనం 3 టైమ్స్ పెంచామనుకోండి, రేట్ నెవర్ చేంజెస్. సపోజ్ నువ్వు వాటర్ తీసుకొని వాటర్ కాన్సన్ట్రేషన్ మనం 3 టైమ్స్ పెంచినా రేట్ ఏమి ఇంక్రీజ్ కాదు. అదే SN2లో దీని కాన్సన్ట్రేషన్ పెంచినా రేట్ అనేది ఇంక్రీజ్ అవుతుంది. How solvent effects? Here solvents are 2 types, that is polar protic solvents and polar aprotic solvents. In polar protic solvents and polar aprotic solvents, that is here polar protic solvents favors SN1 reaction. Polar aprotic solvent favors SN2 reaction. Polar protic solvents means H2O, ethyl alcohol, CH3COOH, and ఇవన్నీ కూడా పోలార్ ప్రొటిక్ సాల్వెంట్స్. పోలార్ ప్రొటిక్ సాల్వెంట్స్ ఉన్నప్పుడు SN1 రియాక్షన్ ఫేవర్ చేస్తాయి. ఇక్కడ పోలార్ ప్రొటిక్ సాల్వెంట్స్ ఏం చేస్తాయంటే అయనైజేషన్ ఈజీగా చేస్తాయి. ఫామ్ అయిన కార్బోకేటయాన్ అనేది పోలార్ ప్రొటిక్ సాల్వెంట్లో స్టెబిలైజ్ అయిపోతుంది. ఇంకోటి ఏంటంటే ఈ సాల్వెంట్స్ అనేది కూడా దీస్ సాల్వెంట్స్ ఆల్సో యాక్ట్స్ యాజ్ ఏ nucleophiles. These solvents are also acts as a nucleophiles. Therefore, SN1 reactions are also called solvolysis. SN1 reactions are also called solvolysis. So this is the effect of solvent. Polar protic solvents SN1 reaction, polar aprotic solvents SN2 reaction. So after solvent, fourth one regarding living groups. So how living group affects the rate of SN1 reaction? Already we are discussed there, that is good living groups favors both SN1 and SN2 reactions. Here also good living groups same, that is good living groups both SN1 and SN2 reaction. This is regarding living groups. So after living groups, heteroatom at alpha carbon favors the SN1 reaction. For example, if you take CH3O CH2Cl, So here if it loses Cl minus, what we get, this is CH3O CH2 this is a carbocation intermediate is formed. This carbocation intermediate here, this is stabilized by resonance, this is stabilized by resonance CH3O double bond CH2 this is a carbocation intermediate, this carbocation intermediate is stabilized by resonance. That means even though it is a primary alkyl halide, but it favors SN1 reaction when compared to SN2 reaction. Why? Because the formed carbocation is stabilized by resonance. This carbocation, it is more stable, it is a more stable carbocation, more stable carbocation. This carbocation stability, it is greater than, even though it is greater than tertiary butyl carbocation. కాబట్టి ఇది SN1 ఫేవర్ చేస్తుంది. ఇది ఇక్కడ ప్రైమరీ ఆల్కైల్ హాలైడ్ ఉన్నప్పటికీ ఇది SN1 రియాక్షన్ ఫేవర్ చేస్తుంది. ఇక్కడ మనం ఏమనుకుంటాం, SN1 రియాక్షన్లో ప్రైమరీ ఆల్కైల్ హాలైడ్ ఫామ్ కాదనుకున్నాం. ప్రైమరీ ఆల్కైల్ హాలైడ్స్ ఆల్సో ఫేవర్స్ SN1 రియాక్షన్. Now let us discuss examples on SN1 reaction. Here this is the first example in this one. This is tertiary butyl bromide. This is chlorocyclohexane. This is tertiary butyl chloride. So we are discussing all these three compounds are treated with water. So what happens? Very simple here, carbocation intermediate is formed, then attacking of H2O. So what we get here, this is OH, this is a tertiary butyl alcohol, this is cyclohexanol, here this cyclohexanol is formed, this is a tertiary butyl alcohol. Here tertiary butyl alcohol, this is tertiary butyl alcohol. Our question is the rate of reaction. So which one undergoes fast and which one undergoes slow? ఏది ఫాస్ట్గా జరుగుతుంది, ఏది స్లోగా జరుగుతుంది, దానికి సంబంధించిన క్వశ్చన్. ఇక్కడ మనకు దిస్ ఈజ్ టెర్షరీ, ఇది సెకండరీ, ఇది టెర్షరీ. ఈ రెండు టెర్షరీ. అప్పుడు దేని మీద డిపెండ్ అవుతుంది, లివింగ్ గ్రూప్ ఎబిలిటీ. Br minus and Cl minus, from top to bottom in a group, living group ability increases. F minus is less than, Cl minus is less than, Br minus is less than, I minus. That is Br minus is a good living group. That means R1 is greater than, R3 is greater than, that is R2. Why? Because this is a tertiary, this is also tertiary, this is a secondary. R1 is greater than, R3 is greater than R2. So here in the second example, sir, what happens, sir? This is iodide compound, cyclohexyl compound. Sir, what happens in this one? Let us discuss the mechanism. Now, so our question is it SN1 or SN2? How can we decide? So very simple, this is a secondary alkyl halide. Secondary alkyl halide may undergoes SN1 and SN2 reaction, TK. Next H2O is a poor nucleophile, this one acts as a solvent, therefore here this one undergoes SN1 reaction. In SN1 reaction, what happens? In SN1 reaction, this is methyl, this is iodide, and loss of I minus takes place. So we get this is cyclohexyl carbocation is formed. This is a secondary carbocation. Already we have discussed, we have one idea. And already we are discussed, that is if any carbocation is formed, there may be rearrangement takes place. Here what happens here, in this one 1,2 methyl shift takes place, 1,2 methyl shift takes place, 1,2 methyl shift takes place. Here this is methyl, this is a carbocation. And this is a tertiary carbocation. It is more stable than attacking of H2O, then loss of H plus. Here we get this product. This is cyclohexyl. This is a cyclohexanol formed. Next, similarly, so in this one, this rearrangement is taking place. 1,2 methyl shift is taking place. Here we got this product. This is a methyl, and here. This methyl is shifted from here to here, we got this product. In this one, sir, which one undergoes more easily cleavage? ఇక్కడ 1, 2, 3లో ఏది ఈజీగా క్లీవ్ అవుతుంది? అప్పుడు మనం ఏం చేద్దామంటే ఇక్కడ సో మూడిట్లో కార్బోకేటయాన్ ఫామ్ చేసి ఏది కార్బోకేటయాన్ మోర్ స్టేబుల్ అవుతుంది దాని రియాక్టివిటీ ఎక్కువ. ఫర్ ఎగ్జాంపుల్ ఫస్ట్ వన్ బ్రేక్ అయింది అనుకుందాం. ఫస్ట్ వన్ బ్రేక్ అయితే ఏమవుతుంది ఇక్కడ, దిస్ ఇస్ CH3, here this is a carbocation. Next, this is which carbon, then second one. Suppose if second one undergoes cleavage, this is first one, this is second one. If the second one undergoes cleavage, what happens? This is Cl, this is CH3, here this is carbocation, this is oxygen, here this is oxygen, here we have Cl, this is also Cl, here we have Cl. And the third one, in the third case, here oxygen, this is CH3, this is Cl, here also Cl, so here this is carbocation. Here the first one undergoes cleavage, that is first Cl undergoes cleavage, so this carbocation is formed. If second Cl undergoes cleavage, we get this second compound. If third Cl undergoes cleavage, we get third compound. In these three compounds, now this is a tertiary carbocation, this is a secondary carbocation, and this is a primary carbocation. Sir, which one is more stable? Everybody knows tertiary is more stable, but everybody is thinking that the first one undergoes easily cleavage. No, here not first one undergoes cleavage. This third one undergoes cleavage. This one is easily undergoes cleavage. Why? Because that is carbocation adjacent atom is having lone pair, that is stabilized by resonance. This is stabilized by resonance. We get this structure. This is Cl, this is CH3, this is Cl, and a double bond O plus. Therefore, this which one is easily undergoes cleavage? This third Cl undergoes easily cleavage. So, now the next one more example on SN1 reaction. Here this is a cyclobutyl compound, here this is a Br, here it is treated with water. So, what happens? Let us consider we don't know it is which reaction, is it SN1 or SN2. So, first of all, suppose if it is given in exam, so how can we proceed? How can we attack this question? How can we solve this question? First of all, see here in reactant which functional group or which groups are present. In reactant Br is present, that means this is an alkyl halide. Alkyl halides undergoes SN1 and SN2 and nucleophilic substitution reactions. So, T here, right, that means we have some idea, that means we got some idea this one undergoes either SN1 or SN2. After that one, sir, we can't, this is a secondary alkyl halide, this secondary alkyl halide maybe undergoes SN1 or SN2. Sir, which one deciding? H2O is deciding, it is a SN1 reaction, that means this one follows SN1 reaction, this one follows SN1 reaction. In SN1 reaction, what happens here, mechanism, in SN1 reaction what happens? This is a, here, this one, this is Br, this is loss of Br minus takes place, loss of Br minus takes place. Here first of all that is a carbocation intermediate is formed, secondary carbocation intermediate is formed. After the formation of secondary carbocation, then 1,2 bond shift takes place, 1,2 bond shift, here 1,2 bond shift takes place. Here what we get, this is here this bond is shifted from this carbon to this carbon, and here this is a secondary carbocation. This is also secondary carbocation, this is also secondary carbocation. This when compared to this one, this is more stable. When compared to this one, this is stable. Why? Because it is 4-membered ring, that is 5-membered ring. 5-membered rings are more stable than 4-membered rings. So, this we can write like this, we can write like this. Here this is we can write like this. This is here, this is a carbocation, where this is, sorry, that not there, here this is a carbocation. So, after this one, this is a secondary, both are same. Now, 1,2 hydride shift takes place. What happens here? 1,2 hydride shift, 1,2 hydride shift takes place. If 1,2 hydride shift takes place, what happens? This one, here it is a tertiary carbocation and it is 5-membered ring, therefore, here shifting takes place. And the next one is attacking of H2O nucleophile, then loss of H plus. So, what we get here, this is the compound is formed. So, this is the compound formed, that is here OH, this is a OH, this compound is formed. So, here this is a 4-membered is converted into 5-membered, and here 1,2 bond is shifting takes place. Similarly, 1,2 hydride shifting is takes place, and the final product is, this is the product. So, this is cyclopentanol, this is the cyclopentanol is formed. So, this is one more example of SN1 reaction. Now, we are going to discuss, that is SNI mechanism. SNI mechanism. So, this is also important. This is also important regarding SNI mechanism. This is nothing but internal nucleophilic substitution reaction. So, where this reaction occurs? So, generally this SNI reaction takes place in alcohols. Here alcohols, when these are treated with SOCl2, this is a thionyl chloride, SOCl2. Generally here we are taking primary alcohols or secondary alcohols. Primary alcohols or secondary alcohols, when it is treated with SOCl2, here we get alkyl halide with retention configuration. Similarly, this one follows SNI mechanism, whereas this primary and secondary alcohols, if it is treated with SOCl2 in the presence of pyridine, In the absence of pyridine, retention of configuration takes place. In the presence of pyridine, here alkyl halide is formed with inversion of configuration. So, just by changing the condition, retention is converted into inversion, and this is a SNI mechanism and this is a SN2 mechanism. Let us discuss that mechanism by taking example. First of all, this SNI mechanism, this one takes place in alcohols, either primary alcohol or secondary alcohol. When it is treated with SOCl2, we get alkyl halides with retention configuration. Same primary and or secondary alcohol, when it is treated with SOCl2 in the presence of pyridine, SN2 reaction takes place and alkyl halide with inversion of configuration takes place. So, here we have alcohol, this is here it is CH3, here it is H, this is C2H5, here it is C2H5, and here it is OH, here it is OH. So, this is treated with SOCl2. So, what happens? Here we get this product H, here this is CH3, here it is C2H5, here we get this is Cl, plus byproduct is SO2 and also HCl. This is which mechanism? This is SNI mechanism. So, what happens in this mechanism? So, here this is H, here it is OH, this is CH3, this is C2H5, this is C2H5. So, SOCl2, S double bond O, Cl, Cl. This is a thionyl chloride. In this thionyl chloride, here this is a thionyl chloride, S double bond O, Cl, Cl, Cl. Oxygen is having lone pair. What happens here? Nucleophilic addition takes place. These pi electrons are migrated towards oxygen. So, what we get here? So, this is H, here it is, this is CH3, and here it is C2H5, here it is C2H5, here it is OH, here it is plus, this is O minus, here it is here it is O minus, and this is Cl, and this is Cl. After this one, what happens here? The negative charge is again migrated here, and here elimination of Cl minus takes place. After the elimination of Cl minus, what happens here? This is H, here it is CH3, this is C2H5, here it is OH, here it is plus, here it is S double bond O, Cl. So, after this one, then here in this one, then the eliminated Cl minus, the last Cl minus, this Cl minus subtract this H plus, Now, this is converted into what? This is H, this is C2H5, here it is CH3, this is O, and this is S double bond O, Cl. So, here okay, దాన్ని ఇక్కడ రాసుకుందాం మనం అదే మాలిక్యూల్ ని ఇక్కడ. So, here this is H, here it is H, this is CH3, this is C2H5, here it is O, S double bond O, here it is Cl. So, what happens here? This is there is no nucleophile. Here HCl is eliminated. HCl is eliminated in the form of gas that is eliminated from the reaction mixture. There is no HCl, there is no Cl minus ion. So then what happens, sir? In this one, the internal nucleophile, this is important, this internal nucleophile attack from the same side of the leaving group. Now this one is eliminated. So what we get here? This is H, this is H, here it is, this is CH3, this is C2H5, this is C2H5, this is C2H5, here it is, this is Cl plus SO2. If you observe the mechanism in this one, this Cl, internal Cl is internally attacking, therefore this is called internal nucleophilic substitution reaction. And here this Cl minus is present, but that Cl minus is abstracting this H plus and it is eliminated from the HCl gas. There is no HCl, there is no Cl minus, there is a nucleophile. Internal Cl, internal nucleophile is attacking, therefore this is called internal nucleophilic substitution reaction. So here alcohol, this is alcohol. Which alcohol? It is a secondary alcohol. It is a secondary alcohol. Here it is treated with SOCl2. We got this is alkyl halide. This alkyl halide, it is a retention configuration. OH at nunchi vellipotundo, Cl kuda at nunchi vachesindi kabatti this is called a retention configuration. Internal ga attack ayindi kabatti this is called internal nucleophilic substitution reaction. Ikkada malli observe chesthe ikkada oxygen paina lone pair undi. Lone pair em chestundi? Sulfur meeda attack ayindi. Adi nucleophilic addition reaction. Pi electrons oxygen వైపు మైగ్రేట్ అయ్యాయి, తర్వాత ఆక్సిజన్ మీద నెగిటివ్ ఛార్జ్ వచ్చింది. నెగిటివ్ ఛార్జ్ వచ్చిన తర్వాత మళ్ళీ బ్యాక్ సైడ్ మైగ్రేట్ అయిన తర్వాత Cl మైనస్ ఎలిమినేట్ అయిపోయింది. ఆ Cl మైనస్ అనేది బేస్ లాగా యాక్ట్ చేస్తుంది. ఈ Cl మైనస్ అనేది ఇక్కడ నుంచి H ప్లస్ తీసుకున్న తర్వాత HClగా వెళ్ళిపోయింది. HCl అనేది వెళ్ళిపోయింది మొత్తానికి. అసలు Cl మైనస్ అనేది రియాక్షన్ లేదు. ఒకవేళ Cl మైనస్ అనేది ఉంటే అది బ్యాక్ సైడ్ నుంచి అటాక్ అవుతుంది. అసలు Cl మైనస్ లేదు కాబట్టి ఇంటర్నల్గా ఉన్న Cl అనేది న్యూక్లియోఫిల్గా యాక్ట్ చేసి దీన్ని ఎలిమినేట్ చేస్తుంది. మనకి ఏమొస్తుంది? ఇంటర్నల్ న్యూక్లియోఫిలిక్ సబ్స్టిట్యూషన్ రియాక్షన్ అండ్ రిటెన్షన్ ఆఫ్ కాన్ఫిగరేషన్. ఇది చాలా ఇంపార్టెంట్ రియాక్షన్. మ్యాక్సిమం ఎగ్జామ్స్లో ఈ SN1, SN2, SNI వీటి మీద చాలాసార్లు క్వశ్చన్స్ వస్తాయి. ఇది చాలా ఈజీ, సింపుల్. కానీ చాలామంది స్టూడెంట్స్ ఏం చేస్తారంటే దీని మీద మిస్టేక్ చేసే అవకాశం ఉంది. కానీ సింపుల్, alcohols plus SOCl2 SNI mechanism. Here this is internal nucleophilic substitution and configuration is retention configuration, not inversion configuration. That is important. So here alcohol plus SOCl2, that is primary and secondary alcohols, SOCl2, the retention of configuration is taking place and that is a SNI mechanism. Sir, if we use pyridine, what happens? If we use pyridine, that is SN2 reaction takes place. So how SN2 reaction takes place? So what is the role of pyridine in this reaction? That we are going to discuss now. Let us take the same example here. Here this is H, here it is CH3, this is C2H5, here it is OH. So this is a secondary alcohol. Irrespective of the nomenclature here, just here we are concentrating mainly on mechanism, not nomenclature. Here this is treated with SOCl2 in the presence of pyridine. The product is, which product is found? Okay, that we will write after the completion of that mechanism. In mechanism what happens, sir? Here this is H, here it is OH, here this is CH3, here it is C2H5. Now the first step is same, that is SOCl2. This is just like a nucleophilic addition reaction. It attacks here on sulfur, the pi electrons are migrated here. So now the next one is here, this is H, here it is CH3, this is C2H5, here it is OH, here it is plus, this is SO minus, this is Cl, this is also Cl. In the next step what happens? In the next step here, in the next step, that is O minus negative charge is migrated here, loss of Cl minus takes place. Loss of Cl minus takes place. Here the reaction is similar to SNI mechanism, but only the slight difference. This step is also we are discussed in SNI mechanism. Here also this one is also same. In the SNI mechanism also same reaction is taking place. This step is also same, here also same. Oxygen is having lone pair, this one attacks on sulfur, the pi electrons are migrated towards oxygen and negative charge is again migrated backside and loss of Cl minus takes place. The Cl minus, this Cl minus, in the next step this Cl minus abstracting this H plus. Here also same, abstracting H plus, here this is H, here it is CH3, this is C2H5, here it is O, and this is S double bond O, S double bond O Cl. Now here we got HCl. So HCl. There also HCl is formed, here also HCl is formed. What is the difference between that reaction and this reaction? Here we are used pyridine. This is a pyridine. This is a pyridine. Oxygen, nitrogen is having lone pair. Now it is treated with HCl. This is a base and this is an acid, and loss of Cl minus takes place. Here we get pyridinium chloride. We get pyridinium chloride. This is NH. Here it is plus Cl minus. In the previous reaction, there is no Cl minus ions, but here we have Cl minus ions. That in that reaction there is no pyridine, here we are used pyridine, pyridine abstracting H plus from HCl, and this is pyridinium chloride is formed, that is Cl minus, this Cl minus is acting as a nucleophile. Now we have free nucleophiles, therefore this Cl minus attacking from the back side of the leaving group. So what happens, sir? Here this is H, here it is CH3, this is C2H5, here it is O S double bond O Cl. Now then next one Cl minus, sir, where is Cl minus? This Cl minus. This Cl minus is attacking from the back side of the leaving group. This is a leaving group. So what we get here? This is Cl, this is H, this is CH3, this is C2H5. So this is chloride is this chloro compound is formed. This is Cl, this is H, this is CH3, this is C2H5, this is C2H5. Here this is ClH, this is C2H5. Here what happened? What is the difference between SNI and SN2? In SNI inversion retention of configuration takes place, whereas in this reaction retention of configuration takes place. This is a retention, sorry, this is not retention, this is a inversion of configuration takes place. Here inversion. This is a inversion configuration, there retention configuration, and here this is a pyridine. Due to pyridine, this becomes SN2 reaction. That reaction is SNI, this reaction is SN2. So far we have discussed what is SN1, what is SN2, and SNI and SN2. In this one, just by changing the condition, this is SNI is converted into SN2. Here pyridine, due to pyridine, SNI is converted into SN2. So now here we have three examples, these three compounds. These three compounds, how these, what about the order of these compounds towards SN1 and SN2 reaction? So first of all, towards SN2 reaction, In SN2 reaction, the reactivity order is primary is greater than, in SN2 reaction, primary is greater than, secondary is greater than, tertiary. Generally, this is the order. In SN2 reaction, that means we need less steric hindrance. Here, so now let us apply this one here. This is a tertiary alkyl halide. This is a primary alkyl halide. This is a secondary alkyl halide. Which is more reactive here? Your primary is more reactive. Therefore, second one is more reactive than, that is third one, this is third one, second one is more reactive than third one is more reactive than first one. This is towards SN2 reaction. So what about SN1 reaction? In SN1 reaction, actually SN1 reaction, tertiary is more stable, more reactive than secondary, secondary is more reactive than primary. In SN1 reaction, so the reactivity depends on, that is formation of carbocation. So here tertiary carbocation, this is first one more stable, that means first one is more reactive than, that is second, third one is more reactive than second one. So in this example, so here, so we have taken these three compounds. In these three compounds, which is more reactive towards SN2 and which is more reactive towards SN1 reaction discussed. Here in SN1 reaction, mainly we are concentrating, that is carbocation intermediate, whereas in SN2, this one processes through transition state. So this is one example. Let us take one more example. Suppose if you take pentane derivatives, 1, 2, 3, 4, 5. This is 1 bromopentane, and here it is 2 bromopentane, and here it is 3 bromopentane. Similarly, here that is isopentyl bromide, 1, 2, 3, 4, 5, isopentyl bromide, and next one here, this is bromide, this is 2-bromo-2-methyl pentane, and next one this is tertiary pentyl bromide. This is the compound 1, this is compound 2, and this is compound 3, and this is compound 4 and 5 and also 6. Now that is reactivity towards SN2. First of all, let us discuss towards SN2 reaction. First of all, it is primary, this is secondary, this is also secondary, and here this primary, and here this is secondary, and here it is tertiary, here it is tertiary. So our question is reactivity towards SN2 reaction. For SN2 reaction, what we need? For SN2 reaction, we need less steric hindrance. Primary is more reactive than secondary, secondary is more reactive than tertiary. First of all, find out here which is primary. This is a primary, and this is also primary. This is primary, this is also primary. That means here this is a open chain structure, it is a branched chain structure. It is having somewhat steric hindrance, that is first one is more reactive than fourth one. After fourth one, this is a secondary, this is also secondary, this is also secondary. Very good. Here we have 3 compounds. In these 3 compounds, which is more reactive? Again concentrate on steric hindrance. Steric hindrance में చూద్దాం. ఇక్కడ తీసుకున్నప్పుడు ఇక్కడ secondary, this is also secondary, and this is also secondary. But in this one, if you observe, this side is we have methyl group, this side is we have propyl group. Whereas here we have this is ethyl group and this is ethyl group, both ethyl groups. In this one, propyl and methyl, ethyl somewhat bulky, and here we have isopropyl group and methyl. Very good example, excellent example. So here steric hindrance is less, 100%, 1 is greater than 4, 4 is greater than 2. Okay. After 2, so which is more reactive? Either 3 or 5. One side we have isopropyl group, here we have this is ethyl and this is also ethyl. This side we have one is methyl group, but here this side is propyl group. That means 3 is almost equal to, that means this is 1 is greater than, right. In this one, that is 3 is approximately equal to 5. 3 is approximately equal to 5. So after 5, then this is tertiary, this is 6th one. So this is reactivity towards SN2 reaction. So SN2 mainly depends on steric factor. SN1 mainly depends on carbocation intermediate. So this is SN2 and SN1 reaction. So now let us discuss some more examples on SN1 and SN2. Here we have Br, the back side we have hydrogen, here we have this is fluorine, here we have. Now this is treated with, here this is a compound, it is having Br and F. Sorry, here it is treated with one equivalence of NaCN. What happens? Here this is a nucleophile, in this one nucleophile is Cn minus. Okay. First of all let us decide it is SN1 or SN2. Here this is a halogen, this is also halogen. We have 2 halogens, and here this is secondary and this is also secondary. Yes, very good, beautiful example. This is also secondary, this is also secondary. Now Cn minus is given. So this is a alkyl halide, either it undergoes SN1 or SN2. Definitely it is a secondary, and here this nucleophile, this Cn minus is a strong nucleophile, therefore it decides is it SN1 or SN2. This is Cn minus is due to Cn minus it becomes SN2 reaction. In SN2 reaction, what happens? That is nucleophile attacks from the back side of the leaving group. Here we have 2 leaving groups, Br minus and F minus. Br minus and F minus, which is good leaving group. Br leaving group ability, F minus is less than, Cl minus is less than, Br minus is less than I minus. Here only one equivalence of NaCN is given. Therefore, this Br minus is replaced by Cn minus. Why? Because only one equivalence. Good leaving group is Br minus, and this Br minus, that is Cn minus, attacks from the back side of the leaving group, and this Br minus is replaced. Here this is present in front side and this is present back side. Then for Cn minus approaches back side, So, the product here, this is the product here, this is front side which comes, this is H is present above the plane, and here Cn minus is present below the plane. Here this is hydrogen and this is fluorine. So, this is which reaction? This is SN2 reaction. This is one example. CH3 C triple bond CH. This is a multiple concept. So, here it is treated with sodium. It gives some X compound. This X compound, it is treated with methyl iodide. So, Y compound is formed. Now, our question is, what is X and Y, and is it SN1 or SN2? Okay. Now, the solution. Sir, how? What happens? CH3 C triple bond CH. Here it is a sodium, it is a active metal. It is a active metal. This active metal replaces this hydrogen. This is an acidic hydrogen. Sir, how you are saying it is an acidic hydrogen? Why? Because this hydrogen is attached to sp hybridized carbon atom. sp hybridized carbon atom, that is due to more electronegativity. As the percentage of S character increases, electronegativity increases. If electronegativity increases, what happens here? Electronegativity increases, carbon and hydrogen polarity increases, therefore, this sodium replaces hydrogen. What we get? This is CH3 C triple bond C minus plus, that is Na plus. So, this is a X compound. Sir, what is the relation between SN1 and SN2? Okay, first of all, we are generated strong nucleophile. This one acts as a nucleophile, this one acts as a nucleophile, and this one also acts as a base, strong base. So, here in this one, now this is treated with, this is a compound X, this compound X is treated with CH3I. This is a primary alkyl halide. Primary alkyl halide, this one undergoes SN2 reaction, it is a strong nucleophile. So, this is SN2 reaction, here this one attacks here and loss of I minus takes place, we get CH3 C triple bond C CH3. This is a but2 ion is formed, this is a but2 ion is formed, but2 ion is formed. Suppose